The date is October 6, 1973. The sun is a merciless hammer over the desert sands. Below, nestled in the arid valleys, the men of the 3rd Air Defense Brigade are confident. They are masters of their domain. Their equipment is the best the Eastern Bloc can produce. A dense, overlapping network of surface-to-air missile systems, controlled by state-of-the-art acquisition radars. They are a steel shield, a mathematical certainty erected against the sky. Their doctrine is a catechism of angles and velocities, a religion of ballistics. The enemy will come. They will fly on predictable paths. The system will calculate their doom. It is inevitable. The sky screams. The alert sounds. On the radar screens, the enemy appears. A wave of fighter bombers, flying low and fast, just as the manuals predicted. The operators are calm, their hands moving with practiced efficiency. The system comes alive. Radars lock onto the targets, their electronic signatures painting them for the kill. The missile batteries acquire the data, their launchers slewing to face the threat. The commanders give the orders. Fire. A volley of steel and fire rips into the air. The missiles, long white darts, climb on pillars of smoke. They are brute force incarnate, unthinking projectiles hurled at a calculated point in space and time. On the screens, the small green dots of the missiles converge with the larger, hostile blips. This is the moment of truth, the moment of impact. But something is wrong. The hostile blips vanish. Not one or two. All of them. One moment they are there, solid targets screaming towards the defenses. The next, the screens are wiped clean. The operators stare. Did they all crash? Was it a malfunction? A strange, powerful jamming signal? The radio crackles with confusion. Before anyone can process the anomaly, a new set of contacts appears. They are small, incredibly fast, and they are flying impossibly low, hugging the terrain like malevolent spirits. The system struggles to track them. The low altitude creates immense ground clutter. But the operators are professionals. They isolate the new threats. The targets are designated. The launchers turn. The second volley is fired. Again, the missiles ascend. Again, the green dots close in. But this time, something utterly impossible happens. The operators see it on their screens, but their minds refuse to accept it. The targets jink. They change course. Not a gentle bank, but a sharp, violent, instantaneous deviation. A hard turn, executed in the final second before impact. The missiles, locked onto a trajectory that was correct a millisecond ago, cannot compensate. They are slaves to physics, to the path they were given. They slice through empty air where the target used to be. They detonate harmlessly against the sand miles away. On the screens, the operators watch in horror as the small, ghostly targets correct their course and continue their approach. They are not flying. They are hunting. A voice screams into the radio. They refuse to die. Another operator, his face pale, whispers, "The missiles they turned, it is a violation of everything they know. A missile is a bullet. You fire it. It flies straight. This is a law, a fundamental principle of their world." Today, that law was broken. The first of the phantom weapons strikes the brigade's central command radar. The screen goes white with static, then black. The shield is blind. The room is a tomb. The methodical destruction of the 3rd Air Defense Brigade has begun. The initial reports from the sun-scorched valley were dismissed. They were filed under the predictable headings of panic, equipment malfunction, and crew incompetence. A brigade, equipped with the most advanced integrated air defense system the Eastern Bloc had ever exported, had been annihilated. But the high command in the distant, cold capital was insulated by layers of bureaucracy and ideological certainty. The official explanation was simple. The crews broke. The hardware failed. The adversary used overwhelming numbers and clever jamming. It was a tactical loss, regrettable but explainable. But then more data arrived. Tapes from the surviving acquisition radars. Fragmentary voice recordings from the final, desperate moments. The stories from the few shell-shocked survivors who were pulled from the burning wreckage. A pattern began to emerge, a pattern that defied all conventional explanation. It was not a failure of men or machines. It was a failure of physics. The reports all said the same thing. The enemy's weapons had maneuvered. They had dodged. They had thought. This trickled up the chain of command, from skeptical colonels to worried generals, until it landed on the desks of the marshals themselves. The problem was no longer tactical. It was strategic. It was existential. The entire military doctrine of the Eastern Bloc was built on a foundation of numbers and mass. A great wall of steel, tanks, artillery, and soldiers, poised to sweep westward. This massive force was protected by an equally massive and intricate air defense umbrella, a shield woven from thousands of missile batteries, interceptor aircraft, and radar stations, all networked together. It was designed to absorb a massive first strike and guarantee the survival of the armored spearhead. That shield was now broken. The incident in the valley proved it. If a small, determined force could use these new weapons to systematically punch holes in their most advanced, densely packed air defense network, then the entire concept was obsolete. The adversary could dismantle their shield at will, piece by piece, leaving the ground forces naked to attack from the air. The great armored fist would be shattered before it could even be thrown. The implications were terrifying. It invalidated decades of planning, trillions in investment, and the core training of millions of soldiers. Their entire theory of modern warfare was based on a simple, brutal arithmetic. You calculate the enemy's trajectory, and you saturate that point in space with firepower. It was a mathematical problem. But the adversary had changed the equation. How do you calculate the trajectory of a bullet that can think? How do you shoot a target that can see you coming and step aside at the last possible moment? The geopolitical balance of power, a delicate and terrifying equilibrium, had been fundamentally altered. The Eastern Bloc's numerical superiority on the ground was its ultimate trump card. That card was now worthless if it could not be protected from the air. The adversary no longer needed to match them tank for tank. They could simply erase the shield and then pick the army apart from miles away with impunity. The industrial might of the state, capable of churning out thousands of tanks and missiles, was suddenly rendered impotent by a phantom. Among the frontline forces, the whispers began. The official explanations were ignored. The soldiers and pilots who had to face this threat knew what they saw. They gave it names. Some called it the Ghost, a weapon that was there and then wasn't. Others called the area of operations the Zone, a place where the rules of war no longer applied, where their missiles would fly true and then inexplicably miss. Paranoia began to fester. Radar operators grew jumpy, seeing phantom returns in the ground clutter. Missile crews lost faith in their equipment. They would go through the motions of a launch, but they no longer believed in the inevitability of the kill. The weapon had become a legend, a monster in the dark. It was not just destroying their hardware, it was destroying their morale. It was a hawk trying to catch a rat in a burrow. The hawk was their missile, fast and powerful. But the rat could always make that one final, life-saving turn. The high command could no longer ignore the crisis. The whispers had become a roar. The strategic threat was undeniable. A special commission was formed, a grim assembly of the best minds from the military's technical institutes, the intelligence services, and the state's sprawling design bureaus. Their mandate was simple and absolute. Find out what the Ghost is and find a way to kill it. The hunt for answers began. The mobilization was swift and ruthless. Teams of intelligence officers and engineers were dispatched to the valley, now a graveyard of blackened steel. They worked under the noses of the adversary's reconnaissance flights, picking through the debris fields like forensic archaeologists. They were tasked with finding physical evidence, any fragment of the impossible weapon. The pressure from the capital was immense. Answers were not requested, they were demanded. Simultaneously, the debriefing of survivors intensified. Men who had already been interrogated were brought back for second, third, and fourth rounds. They were no longer treated as witnesses, but as human sensors. Analysts made them sketch the flight paths of the enemy projectiles on blackboards. They were asked to mimic the sounds the weapons made. Every detail, no matter how outlandish, was recorded. The men were exhausted, haunted by what they had seen. Their testimony was a fever dream of corkscrewing missiles, of weapons that flew with an unnatural, predatory intelligence. They spoke of a system that seemed to anticipate their every move. The most critical evidence came from the radar tapes. In windowless rooms deep within the Ministry of Defense, technicians painstakingly analyzed every second of the battle. The magnetic tapes were played and replayed, the signals amplified and filtered. The truth was there, flickering on the oscilloscopes. The tapes confirmed the impossible. They showed the clean, predictable arc of their own surface-to-air missiles. And they showed the erratic, jagged flight path of the targets. The key moment was always the same. In the final 2 to 3 seconds of flight, just as their SAM was about to intercept, the target would execute a sudden, high-G lateral shift. It was a clean, decisive maneuver, perfectly timed. The SAM, a creature of pure ballistics, had no chance. It sailed on, a ghost killer hunting a ghost. Captured enemy personnel were a dead end. The pilots who were shot down knew nothing. They spoke of a new type of ordnance, a fire-and-forget weapon. They received a target designation, launched the weapon in the general direction, and turned away. The box, they said, did the rest. What box? The interrogators screamed. What is the box? The pilots didn't know. To them, it was just another weapon system, another button in the cockpit. The mystery only deepened. The evidence that was collected seemed designed to confuse. The fragments recovered from the desert were a paradox. Some pieces were from a thick, heavy casing, suggesting a high-speed, armor-piercing missile. Other fragments were light and delicate, almost like parts of a cheap drone, with small, crude-looking control fins. The electronics were even more confusing. Most circuits were fried beyond recognition by the impact and detonation. But some salvaged microchips were unlike anything the Eastern Bloc's engineers had ever seen. The density of the transistors, the fineness of the lithography, it was a generation ahead of their own capabilities. Yet, these advanced components were found alongside surprisingly simple, almost primitive wiring. The investigation was drowning in contradictions. Was it a fast missile or a slow drone? Was it a sophisticated piece of high technology or a simple, disposable weapon? The radar data showed targets moving at over 500 miles per hour. The wreckage suggested something much flimsier. The eyewitnesses described intelligent behavior. The pilots described a dumb box. Nothing made sense. The commission was supposed to find a phantom. Instead, they had found a dozen. The investigation, which was meant to provide clarity, had only deepened the mystery, making the phenomenon seem even more inexplicable, even more impossible. The analysts in the Capitol were staring at a collection of puzzle pieces from a dozen different boxes, and they were tasked with creating a single, coherent picture. They were destined to fail. The commission of analysts and engineers was trapped. They were trapped not by a lack of evidence, but by the rigidity of their own thinking. Their entire education, their doctrine, their industrial base, was founded on a philosophy of brute force and mechanical solutions. When faced with a problem, they sought a bigger engine, a thicker plate of armor, a larger warhead. Their minds were conditioned to look for a physical, mechanical answer. They were searching for a thing, a single piece of revolutionary hardware. This was the magic bullet fallacy. They believed the adversary had invented a miraculous new gun, and if they could just understand the gun, they could build a better shield. They could not conceive that the adversary had instead invented a new way of aiming. Working from this flawed premise, they began to formulate theories, attempting to force the contradictory evidence into their narrow worldview. The first and most popular theory was that of a supermaneuverable missile. They hypothesized that the adversary had developed a revolutionary propulsion system, perhaps a vectored thrust rocket engine or a set of incredibly fast-acting control surfaces that allowed the missile to perform high-G turns in the terminal phase of its flight. This theory explained the radar tapes, but it could not account for the flimsy, drone-like wreckage that had been recovered. A missile capable of such maneuvers would need a robust airframe to withstand the immense stress, not the thin aluminum fragments they had in their laboratories. The second theory was far more paranoid and sinister. It proposed that the adversary had developed an electronic warfare system of terrifying power and precision. This system, they argued, was not just jamming their radars, but was actively hijacking the guidance commands of their own surface-to-air missiles. They imagined a powerful beam of energy that could seize control of their SAMs in mid-flight and steer them away from their targets. This explained why the missiles missed, and it fed into a deep-seated fear of the adversary's electronic capabilities. But it had a fatal flaw. The radar tapes showed their missiles flying a perfect ballistic trajectory. They weren't being steered off course. They were flying to a point in space that the target had already vacated. The missiles were not being fooled. They were being outmaneuvered. A third theory centered on the concept of a new form of stealth technology. The analysts in this camp focused on the initial moments of the battle, when the first wave of enemy aircraft had vanished from the screens. They proposed that the adversary had deployed a squadron of secret, undiscovered stealth aircraft. These planes, they argued, were invisible to their radar systems. The small, maneuvering blips seen later were decoys or secondary munitions launched by these invisible motherships. This theory was appealing because it explained the initial shock of the disappearing targets. However, it was directly contradicted by the radar tapes from the second phase of the attack. The small, fast-moving targets were not invisible. They were clearly visible. They were tracked perfectly, right up until the moment they performed their impossible dodge. Another group of engineers, grappling with the contradictory wreckage, proposed a dual-stage weapon system. They theorized that a large, high-speed missile carried a smaller, drone-like submunition. The main missile would carry the submunition into the target area at high speed, then release it. The submunition, now flying at a much slower speed, would then use its small fins to glide and maneuver towards the target radar. This was the closest they came to the truth, as it accounted for both types of debris found in the desert. But it still missed the essential component. It did not explain how the submunition knew when and how to dodge. They still envisioned it being remotely controlled, a hawk on a leash held by a distant operator. A fifth, more desperate theory bordered on science fiction. It suggested a direct mind-machine interface. Some analysts, overwhelmed by the testimony of survivors who described the weapons as intelligent and predatory, began to speculate that the enemy pilots were somehow mentally linked to their weapons. They imagined the pilot feeling the incoming SAM and instinctively forcing the missile to dodge through a neural link. This was a phantom of the mind, a ghost story born of technological despair. It was easier to believe in magic than to confront the reality that their entire system was obsolete. Based on these flawed conclusions, the High Command issued a series of futile and tragic countermeasures. To combat the supermaneuverable missile, they ordered crews to fire in massive salvos, hoping to saturate the sky and create a kill zone so dense that no amount of maneuvering could evade it. This only resulted in the expenditure of hundreds of valuable missiles, which performed their deadly ballet against empty sky. To counter the hijacking theory, they ordered radar operators to switch frequencies constantly and to shut down their main guidance radars immediately after launch, relying on less accurate methods for the final phase. This made their own systems less effective and did nothing to stop the attacks. They were fighting shadows, wrestling with ghosts of their own creation. Every new order, every new tactic, only made the situation worse, digging their own grave one shovel of flawed logic at a time. While the Eastern Bloc's finest minds were chasing phantoms in darkened briefing rooms, the answer to the mystery was being assembled, not on a military testing range, but in the sun-drenched valleys of a burgeoning technological heartland. The answer was not a weapon. It was an idea, and it had been born years earlier, in the clean rooms and laboratories of commercial industry. The abrupt narrative shift leads us here, far from the battlefield chaos, to a quiet office where an engineer in a short-sleeved shirt is not designing a better rocket, but is staring intently at a small, black square of plastic with delicate silver legs. The true origin of the ghost was not a military project. It was the unintended consequence of a commercial revolution. For 2 decades, a quiet war had been waged in the private sector to make computers smaller, faster, and cheaper. The goal was not to build a smarter missile, but to build a better calculator, a more efficient office machine, a more accessible home appliance. This relentless drive, fueled by competition and consumer demand, had achieved what no state-run, top-down military program ever could: the miracle of miniaturization. The vacuum tube gave way to the transistor. The transistor gave way to the integrated circuit. An entire room of whirring, climate-controlled machinery was shrunk down and etched onto a slice of purified silicon no bigger than a thumbnail. This was the microprocessor. The military did not invent this technology. It merely recognized its potential. A few visionary engineers within the adversary's defense establishment saw this tiny commercial chip and understood its profound implications. They realized that computational power, once a massive, strategic asset housed in deep bunkers, could now be made tactical. It could be made expendable. It could be placed inside a bomb. It could be put inside a missile. This was the core innovation. It was not a new engine or a new explosive. It was the decision to give a simple weapon a complex brain. The system they built around this idea was an elegant fusion of three components. First was the computational advantage itself, a ruggedized, military-grade microcomputer placed directly into the airframe of the missile. This computer was loaded with a simple but deadly set of instructions, a basic logic tree for survival and attack. Second was a new type of sensor. The missile was not blind. It was given a rudimentary set of ears, a passive radio frequency seeker located in its nose. This seeker was designed to do one thing: listen for the specific frequencies emitted by the Eastern Bloc's radar systems. Third, and most crucially, was systems integration. The weapon did not operate alone. It was part of a networked organism. Far from the battlefield, a specialized surveillance aircraft would loiter at a safe altitude, its powerful sensors mapping the enemy's entire air defense network. It identified the location and type of each radar, creating a detailed electronic order of battle. This information was then transmitted via secure data link to the strike aircraft. This system completely demystified the impossible events in the valley. The process was brutally logical. The pilot of the strike aircraft never even needed to see the target. His screen would simply display a symbol indicating the location of an enemy radar, data fed to him from the surveillance plane. He would launch the missile in that general direction and immediately turn away, safe from harm. The missile, now on its own, would fly a pre-programmed route, using a simple inertial navigation system. As it neared the target area, its brain, the onboard computer, would activate its ears, the RF seeker. The seeker would begin listening. Soon enough, it would hear the powerful emissions of the target radar sweeping the sky. The onboard computer would lock onto this signal and calculate a precise course to the source. It was now a bloodhound tracking a scent. When the operators on the ground detected the incoming missile and fired their own SAM in defense, the ghost brain would detect the new, powerful signal of the SAM's guidance radar locking onto it. This was the trigger. The computer, following its pre-programmed logic, would wait until the last possible second, a timing calculated to maximize the SAM's difficulty in adjusting, and then command the missile's control fins to execute a single, hard evasive maneuver. The Eastern Bloc's missile, a product of a bygone era, was a dumb projectile. It was flying to a point in space. It had no ability to react to a sudden change. It would sail harmlessly through the spot where the ghost had been a fraction of a second before. The ghost, having evaded the threat, would then reacquire the original signal of the target radar and steer itself directly into the transmitting dish. The microchip had defeated the smokestack. The weapon wasn't magic. It was a computer executing a simple set of if-then commands faster and more reliably than any human could. It wasn't a better missile. It was the first intelligent one. The breakthrough for the Eastern Bloc came not from brilliant analysis, but from a stroke of luck and the grim realities of war. In a subsequent conflict, a client state's gun crew, firing wildly into the sky with a low-tech anti-aircraft cannon, managed to damage one of the Phantom weapons. It did not explode. Its flight became unstable, and it spiraled into the ground, embedding itself in soft mud, its airframe battered but largely intact. Within hours, Special Operations Forces had secured the crash site, packed the weapon in a crate, and loaded it onto a transport plane bound for the capital. The ghost had been captured. In a secure laboratory deep inside a research institute, the weapon was laid out on a steel table under harsh fluorescent lights. A team of the state's top engineers gathered around, their faces a mixture of excitement and dread. This was the moment of truth. They had spent months chasing shadows, debating theories of impossible propulsion and magical jamming rays. Now, the physical object of their terror was before them. They began the dissection with surgical precision, carefully removing panels and unscrewing fasteners. They expected to find a marvel of mechanical engineering, a revolutionary compact turbine, perhaps, or a series of exotic chemical thrusters for maneuvering. They were prepared to be awed by the adversary's mastery of physics. What they found inside stopped them cold. There was no miracle engine. The rocket motor was a simple, solid-fuel design, unremarkable in every way. The warhead was conventional. The control fins were actuated by simple electric servos. The airframe was cheap aluminum. Mechanically, the weapon was almost insultingly primitive. The engineers stared in disbelief. This could not be it. This flimsy, simple-looking drone could not be the superweapon that had dismantled their most advanced air defenses. But then, one of the electronics specialists pointed to a small, sealed metal box bolted to the missile's central frame, the heart of the machine. They carefully opened the box. Inside, nestled in a shock-absorbent gel, was a single circuit board. It was covered in a dense, impossibly neat array of black rectangular chips and microscopic golden traces. At its center was a larger chip, the microprocessor. The room fell silent. The engineers stared at the board, and in that moment, the full, horrifying truth crashed down upon them. The shock came in three distinct, sickening waves. First was the technological shock. The myth of the ghost was shattered. There was no new physics, no magic ray. The secret was not in the engine or the warhead. The secret was this thing. This circuit board. A computer. The weapon wasn't physically superior. It was mentally superior. It outthought their defenses. It processed information faster. They had brought a spear to a gunfight, and they had not even realized it. Second, and more profound, was the industrial shock. As the engineers examined the microchip under a microscope, a deeper sense of dread took hold. They saw the sheer precision of its construction. The almost invisible lines of the circuits, etched with a fineness their own factories could not hope to match. They understood the concept of a microprocessor, but the reality of this mass-produced, military-grade component was a brutal revelation of their own backwardness. Their industry was built to forge steel, to pour concrete, to assemble massive engines. It was a behemoth of the industrial age. It was not equipped for the microscopic, sterile, dust-free world of silicon fabrication. One of the senior engineers looked at the chip and whispered, "We can't build this." It was not a complaint. It was a verdict. They could not build it to this specification, in these numbers, or with this reliability. Their entire industrial base was a decade or more behind. Finally came the third, and most devastating, wave, the philosophical shock. This was the moment of true humiliation. They finally understood. They had been asking the wrong questions from the very beginning. They had been trying to solve a hardware problem, while the adversary had been solving a software problem. Their entire doctrine of centralized command, of pre-calculated firing solutions, of overwhelming mass, was a relic. The adversary had decentralized the battle. They had pushed intelligence down to the lowest possible level, to the weapon itself. They weren't just building better weapons. They were building a different kind of weapon, based on a philosophy of information dominance, not industrial attrition. They realized, with a sickening certainty, that they were not just behind in technology. They were behind in their very way of thinking about war. The room was a tomb once more, but this time, it was their own illusions that had been buried. The order came down from the highest levels of the state, an edict born of fury and fear. Copy it. It was a simple, absolute command. The captured weapon was to be reverse-engineered, screw for screw, chip for chip. An exact replica was to be produced, and it was to be produced in massive numbers. The nation's pride and its strategic security depended on it. The task was given to the most prestigious design bureau, a sprawling complex that had produced generations of world-class aircraft and missiles. The engineers who received the order knew it was an impossible task. They began the process, dutifully disassembling the weapon and creating thousands of pages of schematics. Copying the mechanical components was straightforward, if time-consuming. The aluminum airframe, the simple rocket motor, the servos, these were things their factories understood. But the circuit board, the heart of the ghost, was another matter entirely. It was an alien artifact. The attempt to replicate the microprocessor was a catastrophe. Their own semiconductor industry was a state-controlled, inefficient beast, focused on producing crude, robust chips for industrial machinery, not the delicate, high-performance processors of the adversary. They lacked the advanced lithography machines. They could not achieve the required purity of the silicon wafers. Their clean rooms were not clean enough. The first attempts to copy the chip resulted in processors that were 5 times larger, consumed 10 times the power, and had a failure rate of over 90%. Even when they managed to produce a handful of functional but inferior copies, they faced the next hurdle, the software. The code was embedded in the chip's read-only memory. They could extract the raw binary, the ones and zeros, but they did not understand the logic behind it. They did not have the adversary's compilers, their development tools, their programming languages. They were like medieval scribes trying to copy a modern textbook, able to replicate the letters, but with no understanding of the grammar or the meaning. They were copying the hardware without understanding the underlying doctrine embedded in the software. The result was a pathetic imitation. The Red Ghost they produced was heavier, less reliable, and had a shorter range than the original. In tests, its crude computer brain would often freeze or guide the missile into the ground. It was a caricature, a hollow shell. The attempt to reverse engineer the technology was a humiliating failure. It exposed a fundamental weakness that could not be solved with a command. The command economy, so effective at producing vast quantities of simple, rugged hardware like tanks, was utterly incapable of fostering the nimble, fast-paced, and quality-obsessed innovation required by the new age of microelectronics. They could copy the box, but they could not replicate the ghost within. The failure was not one of engineering. It was a failure of the entire system. The final scorecard from that first encounter in the sun-scorched valley was a brutal indictment. In the course of a single afternoon, an entire, state-of-the-art air defense brigade had been wiped from the map. 19 advanced surface-to-air missile batteries destroyed. Dozens of radars turned into smoking craters. Hundreds of trained personnel killed. The cost to the adversary, 0 aircraft lost. It was not a battle. It was an execution. A kill ratio of infinity. This single military engagement was more than just a tactical defeat. It was a symptom of a deep, systemic sickness. The Eastern Bloc's command economy, with its 5-year plans and centralized control, had built a military-industrial complex that was a marvel of the mid-20th century. It could produce steel and iron in staggering quantities. But the world had changed. The future of warfare was not being forged in blast furnaces, but in the sterile, clean rooms of the semiconductor industry. The new measure of power was not tons of steel, but processing speed. The adversary's strength came not from a government directive, but from a vibrant, chaotic, and relentlessly innovative commercial sector that was, incidentally, producing technologies with profound military applications. The Red Command was playing checkers, while the West was playing chess on a board they couldn't even see. The systemic flaw was philosophical. The Eastern Bloc believed in the power of the collective, the centrally controlled mass. Their military was a reflection of this, a rigid, hierarchical pyramid where orders flowed from the top down. Initiative was punished. Deviation was heresy. The adversary, by contrast, was beginning to build a system based on a different principle, the empowered edge. By placing a computer inside a missile, they had decentralized intelligence. They had given the weapon itself the authority to make its own life-or-death decisions in the final seconds of battle. They were building a network, not a pyramid. A resilient web of smart, interconnected nodes, not a brittle, centralized monolith. It was a war between two opposing theories of power, and information was defeating brute force. The legacy of the Ghost was the dawn of a new era in warfare. It was the first shot in what would become known as the revolution in military affairs. The concepts it pioneered, precision strike, network-centric warfare, information dominance, would come to define the battlefields of the next half-century. The image of a single, smart weapon dismantling an entire conventional defense network became the driving force behind a generation of military innovation. The race was no longer for the fastest plane or the biggest tank, but for the smartest chip and the most sophisticated algorithm. The Red Command had spent decades preparing for a war of attrition, a colossal clash of steel titans on the plains of Europe. They had built an army to fight the last war. They never realized that the next war had already begun, and they had already lost. It had been won years before, not on a battlefield, but in the quiet, air-conditioned laboratories of a commercial industry they barely understood. It was won by a small slice of purified sand that had been taught how to think.